I request all participants to please keep their mics on mute and switch off their videos for better bandwidth. And I also request all the participants to please rename themselves with the addition of their college names. Thank you. A very good afternoon to everyone present. On behalf of HSNC University, KC College, I, Mr. Siddharth Nakhwa, your host for today, would like to welcome you all for the inaugural ceremony of our 3-day workshop, Bandit Up, an interdisciplinary approach to techniques in chromatography. This is an interdepartmental activity and a state-level workshop arranged by the Department of Life Sciences and Department of Chemistry, KC College, under the aegis of DBT star status. Our pillar of strength, our very own principal, Dr. Hemlata Bagla, could not be with us today due to prior commitments, but she sends us her best wishes. Thank you so much, ma'am. Now, I would like to call upon our ever enthusiastic Vice Principal, Faculty of Science, Dr. Tejashree Shanbag, to do the honors and address our participants.
Good evening to one and all present. You can hear me?
Yes, ma'am, you are audible.
Yeah. Good evening. It gives me a great pleasure to be part of this interdisciplinary workshop on chromatography techniques that is organized jointly by the Department of Life Sciences and Department of Chemistry under the aegis of DBT star status. I thank Dr. Sagarika Damble, coordinator, DBT star status, and Dr. Sheila Valecha, head of the chemistry department, for giving me an opportunity to speak over here. I take this opportunity to welcome each one of you to the 3-day hands-on training workshop on techniques in chromatography. Principal Hemlata Bagla could not be a part of today's inaugural program as mentioned by Siddharth earlier due to her prior engagements. Nevertheless, she has conveyed her best wishes. She has always been the guiding force and has always encouraged and motivated us in conducting such programs. Coming to this topic of the chromatography techniques, I would like to say over here that chromatography is one such topic which happens to be one of my favorites. Students, you are going to be benefited in this hands-on training program. You will be introduced to the basics of chromatography, its principles, types, and applications. No doubt some of you must have come across it in your earlier classes, but nevertheless, getting into a detailed will benefit us all at large, because it's chromatography is enlarging it. Day by day, new researches are coming into it, which will help us to enhance our knowledge too. You have very talented resource persons to take you through this 3-day workshops. We have Dr. Yogita Shinde, Dr. Charulata Chaturvedi, and Dr. Mayuresh Joshi. So without much ado, all the best to all the organizers and the volunteers. Thank you.
Thank you so much, ma'am, for those pleasant words. Now, I would like to invite our Vice Principal, Coordinator of Examination, Mr. Justin Maria, to speak a few words.
Hello, good evening, all of you. On behalf of KC College Principal and Vice Principals, I congratulate the Department of Life Science and the Department of Chemistry for organizing this workshop. I wish the program all the very best. Thank you.
Thank you so much, sir, for engracing us. Now, I would like to invite our supremely talented coordinator, DBT star status, head of Department of Life Sciences, Dr. Sagarika Damble, to give an overview of the workshop to our participants.
Thank you, Siddharth. It's with a great pleasure and happiness in my heart that I welcome everyone, as our VP ma'am has already welcomed. Justin sir, thank you so much for being here. But as the department coordinator, along with Sheila Valecha ma'am, who's from chemistry department, I once again welcome you all. And I think before giving you an overview, I want to just highlight the things that happened before that actually led to this workshop. So we were fortunate enough to receive the STAR scheme grant from DBT, Government of India, in 2016, which basically focused on strengthening the skills of undergraduate students. We really worked hard for 3 years, and in 2019, we were granted the star status. So from scheme to status, we realized that what is needed is the skill enhancement of especially science students who are going to then later on enter into the industry. So this workshop of today was not only our thought process, as I just mentioned, but also because our advisory committee, which were comprising of stalwarts from this field, like Dr. Sunita Shailajan, Dr. Nishigandha Naik, they always insisted, and they said that working in silos or working individually as a department does not help, because today's buzzword is interdisciplinary. So you have to work together. And that is why I think it's really great that the Department of Chemistry has joined hand with Department of Life Sciences for this today's workshop. As you know, chromatography belongs to almost all disciplines if we look at it that way. So Bandit Up, or the chromatography technique workshop, is definitely for the next three reasons that I'm going to speak on. That is, one, to bridge the gap between the industry and academia, to inculcate interdisciplinary approach in students, but also very importantly, to expand our horizons as the star status college of knowledge seeking and sharing using this online platform beyond our own college. And I'm very happy to know that we have members here, not only from Mumbai colleges, but across Maharashtra, from Vengurla, from Mahatma Phule College. I'm so delighted. And originally this workshop was for undergrad students, but I'm very happy that we have got some uh, participants which are from MSc, and there are some staff members, some from our college and some from other colleges as well, who have joined it. So I think as a coordinator of star status activities at KC College, I'm so glad that we are all here together on this online platform for the next 3 days to share our expertise and to exchange our understanding regarding these techniques. I hope everybody knows here it is a huge challenge during online sessions to show demonstrations. But I think we have supremely talented teachers with us, as already mentioned by Shanbag ma'am, that we have tried at our end to be, to give you the most that we thought of would be of importance in developing these techniques or skills, and some of the things which we can try at home ourselves, even during these lockdown days. So for day one, we have the basics of chromatography, lecture on basics of the technique as such, which will be delivered by Yogita Shinde ma'am. On day two, we are going to have HPTLC and its use in standardization of herbal products. Again, this will be delivered by Mayuresh Joshi, and you all know that HPTLC is now become not only inaccessible, but you can have an access to this instrument throughout the research institutions and some industries. And students who graduate after taking chemistry or biological sciences are expected to know some of these instrumentation. So this second day's HPTLC session, I'm sure people are going to enjoy. And the third day is the best, I think. It's the most exciting one. So the excitement goes on increasing per day. And the day three has an interactive session and hands-on training practicals majoritarily, where the brainstorming session on possible applications of these chromatography techniques in small projects, because nowadays projects has also become a buzzword. Every other college has something, some activity related to project. So that will be there. And of course, the hands-on activity by Charu ma'am, which will be lab it up at home, which means you can try out these experiments at home as well. As I said, resource person for this will be Dr. Charu Chaturvedi. So I'm sure with this very brief overview of 3 days, I'm not going to take much of your time, but at the end, I want to thank Dr. Sheila Valecha ma'am and the entire chemistry department for coming together with life science department for this very, very exciting Bandit Up. All the student volunteers, all teachers who have been there, I think a formal vote of thanks will come later. But we are all looking forward to spending these 3 days with all the participants and let's band it up. Thank you so much. And I'm sure Principal Ma'am is there in spirit with us, and she will be with us on one of the days because she is the main pillar behind all the activities that go on in KC College. So I thank Justin sir, and of course, back to you, Siddharth.
Thank you so much, ma'am, for for the guidance and those kind words. Now, I would like to invite Dr. Sheila Valecha, Associate Professor, Department of Chemistry, to propose the vote of thanks for the inauguration.
Thank you, Siddharth. Respected vice principals, chairperson, status, our most valued invited guests, student participants, and our faculty members. It's my privilege to have been asked to propose a vote of thanks for this occasion. At the outset, I thank our principal ma'am, Dr. Hemlata Bagla, Dean Science and Technology, HNC University, to encourage the teachers to organize a workshop on chromatography on a magnitude scale. Dr. Bagla, a dynamic personality, avid researcher, is the backbone of growth in all the departments. She is keenly interested in interdepartmental activities and interactions, and hence a workshop organized together by chemistry and life science. Since Dr. Bagla heads the different post and number of posts, today it was not possible for her to join us on this occasion, but not to forget that in spirit she's always with us. Thank you, Dr. Bagla, for encouraging and doing all the things for students and the college. I thank Vice Principal Dr. Shanbag for joining and welcoming the guests and student participants on behalf of Principal Madam. I also thank Vice Principal Mr. Padi, Dr. Shalini, and Mr. Justin for their presence, help, and guidance. Gratitudes are due to Dr. Damle, coordinator for Star Status, for her efforts in jointly taking the responsibility for organizing the workshop under the aegis of Star Status. Thanks are due to organizing committee comprising of life science and chemistry teachers, and of course, ever energetic student volunteers for their hard work to keep and arrange every single bit on place for smooth running of the workshop. My chain of thanks would be incomplete if I don't mention about the student participants. The student participants from KC and all over colleges around Mumbai and outside Mumbai, and the faculty teachers, a big, big thank you to all of you. Thanks are also due to faculty members from KC College for coming and gracing the occasion. Thank you and wish you all the best for the coming 3 days workshop. Congratulations for the organization of the beautiful and colorful workshop on chromatography. Thank you. Thank you. All the best.
Thank you so much, ma'am. Before we begin with the session, I would like to invite Ms. Riya Navalkar from TY, Department of Life Sciences, to introduce our resource person for today.
Thank you, Siddharth. It is my absolute pleasure to introduce our speaker for today, Dr. Yogita Shinde. Dr. Shinde ma'am has completed her BSc from Mumbai University. She has completed her MSc in Analytical and Medicinal Chemistry from SNDT University. Ma'am got her PhD in Bio-Inorganic Chemistry from University of Mumbai. Her research interests include analytical chemistry, medicinal chemistry, natural plant products, and environmental chemistry. 10 of ma'am's research papers have been published in peer-reviewed journals. Dr. Shinde has worked as a lecturer in Birla College, Kalyan from 2004 to 2005. Ma'am is currently working as an assistant professor in Department of Chemistry, KC College since 2005. Dr. Shinde has been the chairperson for MSc Analytical Chemistry, University of Mumbai. She has also worked as the member of Syllabus Revision Committee for TYBSc, University of Mumbai. Ma'am is a member of BOS in Chemistry, HSNC University, Mumbai, Dr. Shinde is also a chairperson for BOS in Biochemistry at HSNC University, Mumbai. We're so glad to have you, ma'am. Thank you.
Thank you, Ria.
Thank you, Ria, for those words.
Yes, ma'am. Yes, ma'am. Ma'am, before we start the session, I request all the participants to please keep their mic muted and keep their videos off for better bandwidth. And I also request the participants to please keep a watch on the chat box as the links will be posted for the questionnaire, pre-questionnaire, and the feedback form. I would also like to request the participants to please rename themselves with the addition of their college names beside their names. Thank you. Now, all over to our resource person for today, Dr. Yogita Shinde. Welcome you.
Thank you, Siddharth. And on behalf of KC College, HSNC University, I once again extend a very warm welcome to each one of you. I'm sure in the coming 3 days, we are going to have a very good experience of how chromatography works. Before I start with my talk, I would like to give you a few concepts that I'm going to talk on. The workshop is totally meant for, it is having an interdisciplinary approach. So we are not going to talk or cater to only one subject as such. It is going to be in general related to life sciences, related to biological sciences and chemistry. Now, what I'm going to do today is we are going to start with some basics of chromatography. I totally understand that most of our students are undergraduate students. So it is very clear that we will not be, going into deeper details of the topic. We will be talking about the very, very basic aspects of why, how, and what. Okay, now before we go ahead, please refer to your chat boxes. In your chat boxes, I will be putting up a link for a Google form. I want each one of you to access the form. This is a free activity for today's session. I'll explain the concept of what is pre and post activity right now. Just access the form and please, you can submit the form with your responses. It is just a pre-event activity, rather a pre-activity for this event. You can see, all of you can see the link that I have put in the chat box. We'll give you a time of 10 minutes. You can access it, submit your responses, and then we will proceed. You can start now. I'll be on mute for those 10 minutes. I hope people are submitting the responses. This activity is just for us to understand what exactly people know about chromatography. So this is sort of, a warm-up exercise for the entire activity that we are going to have for 3 days. We are getting responses. I want people to speed up. Please send in your responses. I put in the link for the form again. In case anyone has got disconnected, kindly refer to the chat box for the link to Google form. I'll repeat, this is just for us to know how much people are aware about chromatography. No marking will be done. It is just for our understanding. And it's an earnest request. Once I begin with the session, I want people to put yourself on mute, switch off your videos. Anurag, how much more time do we wait for?
Ma'am, only 60 responses are there.
Okay. I'm putting the link once again in case anyone has missed it. We'll be closing the link in another 3 to 4 minutes. I hope everyone has attempted. Good. We are getting responses. I hope everyone has renamed yourself in the way Siddharth has instructed each one of us. Siddharth, can you unmute and tell people the sequence of renaming?
Yes, ma'am. I request all the participants to please rename their cells with their names first, followed by their college names, college or institution names. Again, I request everyone, all the participants, to please rename themselves by adding their names followed by the institution or college names. Thank you.
Mayuresh sir, should we close the link now?
Ma'am, I think you can proceed with the session. The link
Yeah,
will be
I'll start with the session.
yes. Students can submit their forms and the link will close. Thank you so much, ma'am.
Okay. Now, let us start with today's session. First and foremost, let me tell you that we are in the age of interdisciplinary science. So nowadays, there are no watertight compartments of chemistry and physics and microbiology. If you need your work to benefit the society, it has got to go interdisciplinary. And that was purely the approach in organizing this kind of workshop, wherein people who don't know what they are going to do in their final year or who are not yet sure of what they are going to do in your final year can benefit from this. At the same time, we have tried to keep it as basic as possible so that your basic concepts of chromatography and its applications get clear. Now, as you can see on this slide, I have shown you different types of separation techniques. Now, what is a separation technique? As the name suggests, any method that you use to separate components of a mixture. The moment I say mixture, you are supposed to understand that it could be a homogeneous mixture, it could be a heterogeneous mixture. All right, so let us identify. I'm going to use a pointer. So you can see this here. Yes, this technique you can talk of as filtration. Each one of us uses filtration when we prepare tea at home, right? Then this is evaporation. This technique is decantation. Of course, nowadays decantation we see only in the labs. You don't see it at home. In times when there was no aquaguard, there was no water purifiers, no RO systems, our grandmothers used to use this technique to, separate clear water from mud or silt, especially in villages in the rainy season, wherein there is, because of a huge mixing of water resources, the water that you get at home is muddy. So this is, of course, nowadays we use it in the lab only. This is magnetic separation, generally used from the chemist point of view in metallurgy. Then you can see this is solvent extraction. This is, the two techniques are what you call as distillation techniques, right? Sorry. So these are the distillation techniques. Now, let us proceed. Now my point is very simple. Why or what is separation? So what are these techniques? These are a collective techniques which can be used to separate two different states of matter or two substances in the same state. Like if I have acetone and water mixed together, they form a one-phase solution. So I can use this technique for separation of acetone and water. Next most important question, why? Why do you need to separate? You can see the three pictorial demonstrations talk about it themselves. First, to identify what you have to separate it, what you have to be separated from the mixture. Then, to obtain important and pure substances. And third, a very angry emoji saying stop, to remove unwanted particles or to remove things which you don't want. Now, I'll talk about this from the point of view of a pharmaceutical industry. When a pharmaceutical industry manufactures a drug or modifies a drug, The first thing is the starting raw material has to be pure. They cannot afford to use impure raw material because ultimately it will affect their productivity, and secondly it will also affect the safety of the product. So you have to remove unwanted substances. You want pure substances, right? And then to identify what is there in the mixture. This is purely, whatever I'm talking of here is purely a research point of view. These are the separation techniques. This is just an overview. Now the separation technique that you're using depends on the type of mixture. So if you have a solid and liquid mixture, which is homogeneous, right? You can use distillation. It is heterogeneous, you can use sedimentation, you can use filtration, you can use magnetic separation, you can use fractional distillation. For liquid-liquid mixture, fractional distillation, chromatography are the methods of choice, and partition chromatography again being used. Now these are representations of a few techniques. You can see the sedimentation. You allow the impurities to settle down, simple logic. As you're talking of solid impurities, they have high densities. So if you keep them undisturbed for some time, the density will make those impurities settle down, and then you can just siphon off the clear liquid from the top. That's called as sedimentation. Then this is decantation. I told you already. What you do is you allow the sediment to settle. Instead of siphoning off from the top, you just pour off the clear supernatant and remove it and separate it. So these are our age-old techniques. Then this is what we use at home every day. Whenever you prepare tea, you separate the used tea leaves by filtration. It is also called as sieving. You use a sieve. Of course, the size of sieve will decide how much separation you are achieving. Then this is what we use in the lab. It is called as a centrifuge. What does the centrifuge do? Basically, it helps you to separate substances according to their densities. Then you have evaporation and crystallization. Then this is simple distillation. Now, I just brought these techniques just for us to know where and how to use separation. Right? This is again crystallization, and most important, sublimation. I hope every one of you is aware of what is sublimation. There are certain substances like ammonium chloride, iodine. When you heat them, generally क्या होता है? When you heat a solid becomes a liquid, and a liquid becomes a gas. There are some substances in which the solid directly gets converted to the gaseous state without going through the liquid state. We call them as subliming substances. So if I have a mixture of, say, potassium chloride and ammonium chloride, what is shown to you on the screen, of which potassium chloride does not sublime, ammonium chloride sublimes. So when you heat it, ammonium chloride goes to the gaseous state, and you can see on the colder parts of the funnel, that is this portion of the funnel, the ammonium chloride starts depositing, and finally you will come to a stage where only potassium chloride remains here and entire ammonium chloride comes here. This is again a very classical or very what you call as conventional separation technique. Now we come to, the hero of today, chromatography. What is chromatography? Let me explain the term first. The word chrome is color. So visualization of color is chromatography. Please don't take the verbal literal meaning. Let us understand how this began. It began with people trying to separate chlorophyll pigments. So when chlorophyll pigments were separated, they gave different colors. That's the way the technique got its name, chromatography. So it's a separation technique used to separate different components in a liquid mixture or in a solution form. So first thing, when you are doing chromatography, your sample has to be in the solution form only, right? So you dissolve the mixture in a fluid called as the mobile phase, which carries it through a structure holding another material called as the stationary phase. I'm going to do this later on, so don't worry. Now, why chromatography? You know why people are attracted to chromatography? All biological sciences, all chemical sciences, all organic synthesis, all pharmaceutical industries, everywhere we use chromatography. The question is why? Because with chromatography, you can separate mixtures which have very identical physical or chemical properties. Second, it's a gentle method. By gentle, I mean we are not using too many harsh chemicals. Third, it's a very sensitive method. Even if the concentration is in micrograms, you can use this technique. And most important, what we all aim at is simple, rapid, efficient. So you don't require too much of equipment. It's a fast way and it's a very efficient technique. Comparing it to the time and the effort that you put in, the results are commendable. So that's the reason chromatography is preferred over other methods. Let us go to the history of chromatography. I will say the father of chromatography was Sweat. He employed this technique to separate pigments like chlorophyll, xanthophylls by passing them through a column which was finely divided calcium carbonate. So the first ever stationary phase that was used was calcium carbonate. What is calcium carbonate? Something like a chalk. Then the concept of GLC, gas liquid chromatography, was introduced by Martin and Sage. Then from the Martin's laboratory, separation of amino acids was done by paper chromatography. Martin and Sage were awarded the Nobel Prize for explaining or for establishing the importance of chromatography in 1952. In 1959, there was a technique introduced called as gel filtration chromatography. And what was the advantage of this technique? It was used to separate low molecular weight substances from high molecular weight substances. Then, in 1960, liquid chromatography was modified further to high performance liquid chromatography, which you are going to talk about tomorrow, HPLC. Then, 1970, you had adsorption chromatography, which was mainly based on biological interaction. Then came supercritical fluid chromatography. It is a hybrid of GLC and liquid chromatography. So it uses both the features of both gas solid chromatography and liquid chromatography. In fact, the entire 20th century can be named as the century of chromatography. In fact, let me tell you very clearly. When we do practicals in chemistry laboratory, when we are doing organic synthesis, the best way to find out whether your reaction has happened or not is chromatography. It gives you a precise idea of whether your reagents have been used up, whether a new product has been formed. So that is why today it is an essential technique. Anyone who wants to go further in the field of science, whether it is academics, whether it is industry, whether it is research, we are supposed to be aware of the technique of chromatography. So now let us begin. It is used to separate and identify components. How does it work? It allows the molecules to distribute between a stationary and a mobile phase. Simple logic. Those molecules which like the mobile phase move faster. Those which do not like the mobile phase stay back. I repeat my point. The molecules which like the mobile phase move faster. Those which do not like the mobile phase lag behind. Okay, so now why scientists prefer chromatography? The results are reproducible, better accuracy, complex mixtures can be easily separated, less time consuming and cheaper. In fact, today, tomorrow, day after tomorrow, you'll get to know we all can do chromatography at home. These are the examples of chromatography. So what are we having here? We are having first liquid chromatography, okay, which we can also call as partition chromatography. Then you have thin layer chromatography. I'm going to discuss this in detail. And finally, paper chromatography. What does paper chromatography do? It uses a filter paper. Now, each one of you, of course, we have not been into the lab for 1 year, but I suppose each one of you remembers the feel of a filter paper, right? Many of you must have heard of the term Wattman filter paper. So when you're doing a paper chromatography, you use a Wattman filter paper. What could be the reason that we don't use an ordinary filter paper? You know what is the reason? Your ordinary filter paper does not have even arrangement of fibers. Whereas in Wattman filter paper, the fibers are evenly arranged. So there is less resistance for the movement of the solvent as well as the solute particles. Same way, a better version of paper chromatography is your thin layer chromatography. Why? Because what you do, you take a solid support, maybe like an aluminium plate, or maybe like an aluminium foil, or a glass slide. You coat that solid support with silica gel. You activate the plate at a temperature of around 100 to 120 degrees, and then you use that for chromatography. Basic advantage, paper chromatography is easy to do, anyone can do it, anywhere you can do it. But if you are talking of any kind of corrosive chemicals, any kind of harmful chemicals, then paper chromatography is little bit dicey. Whereas since your thin layer chromatography uses a solid support like glass on which you embed silica, it becomes more, not prone to corrosion. So whenever you're using harsh chemicals, whenever your sample itself is corrosive, paper chromatography won't work because paper will get corroded. That's where we replace it by TS. Now, let us come to a representation of what it is. As I've already told you, we are separating mixtures to analyze, identify, purify, and or quantify the mixture. So what you try to do is, you separate it, first step. Second step, you find out what it is. Third step, if required, you purify the components. And fourth step, you can even find out how much amount is there. Right? So now let us understand what is done here. Here you are having 4 different components. Okay, they are shown in different colors. I got this very good representation on the net the other day, so I took it away. You are having a yellow component, a red component, a blue, and a black. Right? So your mixture is having all of this. So with chromatography, what you do? You separate each of this. Yellow को अलग कर दिया, red को अलग कर दिया, blue को अलग कर दिया, black को अलग कर दिया. Right? You separate all these components, and then you can, identify, purify, quantify each of this component. This forms a very important. I'll give you a very good example. Suppose let us take something as simple as something that you get in your kitchen. Say, for example, you have some spice, or maybe some something like turmeric. So you prepare an extract, right? You take the turmeric extract, you carry out chromatography, you can be able to find out what are the components in turmeric extract. If you are furthermore interested, you can separate each of the component, identify what it is. And from literature, you can find out where and how that component is useful. Right? Suppose I'm talking of, say, for example, a plant like, say, eucalyptus. So So what is that part of eucalyptus, or which is that extract of eucalyptus which is actually effective as a medicine? You can first take the extract, you can subject it to chromatography, you can find out which different components are there. Each individual component you can identify, analyze, purify, etc. So this is how chromatography is applied. Now you can see this, right? You can see this, the mixture is having all the 4 things, right? 3 things here, blue, red, yellow. So when you allow it to move, blue, black, red, yellow, all of them get separated, right? Now, let us understand. The stationary phase is the support that you are having. If you are having paper chromatography, your paper with the aqueous solvent becomes your stationary phase. Right? You have a mobile phase. So what you do now, you allow your mobile phase to move up. This movement is by capillary action. I'm going to demonstrate today how the movement happens. So this movement is by capillary action. Now what happens is, the blue stays behind. After that, black. After that, red. After that, yellow. Now what can I make out from here? My yellow component has got a huge affinity for mobile phase. Matlab, to put it in very simple terms, जो मेरा yellow वाला component है, it likes the mobile phase, so it goes with the mobile phase as far away as possible. Red भी mobile phase पसंद है थोड़ा सा. So what does red do? थोड़ी देर के बाद red says no भाई बस हो गया, अभी मुझे आगे नहीं जाना. Right? So the affinity of red is less than the affinity of yellow to the mobile phase. And black wala, uska red se bhi kam affinity. And blue wala is very adamant. It says, no, I don't want to leave the stationary phase at all. I like stationary phase. I don't like mobile phase. So the blue wala thing stays back. What do you understand from this? Jo spot further away nikal jata hai, that spot has got more affinity for mobile phase. The one which stays back has got more affinity for stationary phase. So you can see this table here. The blue does not like the mobile phase, so it stays where it is. The black likes stationary phase, and thoda it likes the mobile phase. रेड का सिचुएशन उल्टा हो गया. रेड को स्टेशनरी फेज कम पसंद है, मोबाइल फेज ज्यादा पसंद है. एंड येलो इज भक्त ऑफ मोबाइल फेज. इट प्रेफर्स टू गो विद द मोबाइल फेज ओनली. Yes, I hope people are, getting what I'm trying to tell you. What do chromatography mechanisms depend on? They depend on adsorption, partition, ion exchange, and size exclusion. Now, what are these techniques? Adsorption, each one of us knows, who has done basic science till 12th standard. Adsorption is the surface phenomenon of, attraction between an adsorbent and an adsorbent, right? Partition. Suppose now, let me give an example and tell this. Suppose I'm having, say for example, iodine. I dissolve iodine in aqueous potassium iodide. Okay. And I put chloroform in it. So now I'm having 2 phases. There is chloroform, which is the organic phase. There is potassium iodide, which is the aqueous phase. So now this iodine likes to go in both the places. It likes to go to chloroform also. It likes to go to potassium iodide also. So we say iodine gets partitioned between 2 phases. So if I have iodine having greater affinity for chloroform, majority of iodine will go in the organic phase. A very small amount will stay in the aqueous phase. If it is vice versa, what will happen? Iodine has got more affinity for aqueous phase, then majority of iodine will stay in aqueous phase. A small amount will go in the organic phase. So when you are using this fundamental, you call it as partition chromatography. Then you have ion exchange. Now let me show you ion exchange. Suppose this is a resin, right? On the surface of the resin, I have H plus ion. Okay. Now the situation here is the resin has H plus ion. So what happens here? If I allow any other ion, which is say M plus, I'm sorry, what will happen now? This M plus will come to the surface of the resin and this H plus will move out. You call this as ion exchange, right? When you're using this property to separate, we call it as ion exchange chromatography. Then you have size exclusion chromatography. So let me tell you what is size exclusion. Suppose this is, say, a sort of a bag, right? On this bag, I have, let us say, sorry, this is the bag. The surface of the bag has got some pores, and these pores have got a size, say, 1 micron. Okay, now I have a mixture in which I am having 2 micron, 3 micron, 0.5 micron particles. Now I put this bag here. So now what is going to happen? What will happen now? Let us understand. I repeat my point again. I have a bag which is porous. The size of that bag or pore size is 1 micron. मतलब 1 micron से कम size वाली चीजें ही अंदर जा सकती है, बाकी सब बाहर रहेगा. So what do I do now? I keep this in a solution which has got, particles of different size. अभी क्या होगा? ये सारे eliminate हो जाएंगे. Only 0.5 micron वाला जो particle है, it will enter inside. This is size exclusion. The concept I have told you in very simple terms. Of course, the concept is more complicated. I won't go into the details because we don't need it right now. So this is size exclusion chromatography. Now, let us go to the next slide, please. So now let us understand in detail. Adsorption, it depends on relative polarities. Compounds having high affinity to the stationary phase move slower, and those which have less affinity to the stationary phase move faster. Okay. So here what we do, we talk of affinity of a solute to a stationary or a mobile phase. So if a component of the solute likes a mobile phase, it prefers to move as far away as possible along with the mobile phase. मतलब वो क्या है? Mobile phase जहाँ तक जाएगा, I will come with you. That's it. If it does not like the mobile phase, I'm using very colloquial terms because I want you to understand. I don't want you to know scientific words that you can anytime find out. So when I'm talking of a stationary phase or I'm talking of a molecule having affinity to stationary phase, तो mobile phase को बोलेगा तुम जाओ मैं नहीं आ रहा. So I will stay where I am. So that kind of chromatography uses the concept of adsorption. Partition, relative solubility of a solute in two different solvents or in two different phases. So what happens here? Those which are more soluble travel slower. Those which are less soluble travel faster. Then ion exchange. So your stationary phase will have fixed charge groups. And what will happen is, as you pass your sample through it, ions from the sample will get exchanged on the stationary phase. Then you have size exclusion. I have already told you, particle size se separation hota hai. Okay? Now, these are the techniques, or these are the classification of chromatography. First, you classify it on the basis of interaction of solute to the stationary phase. So, what do you have here? You have adsorption chromatography, you have partition chromatography, you have ion exchange chromatography, you have size exclusion chromatography. Fine? Then, on the basis of the chromatographic bed shape, in this you have two-dimensional and three-dimensional. Two-dimensional means you have TLC and paper chromatography. In three-dimensional, you have column chromatography. Then the third classification is on the basis of physical state of the mobile phase. If your mobile phase is in the liquid form, you have liquid chromatography. If your mobile phase in the gaseous form, you have gas chromatography. A combination of both of them is supercritical fluid chromatography. I will go through this again. Your entire chromatography technique you classify into three basic types, or rather on the basis of interaction of solute to stationary phase. These are the four things that we have already studied just now. Adsorption chromatography, partition chromatography, ion exchange chromatography, size exclusion. Matlab, the basic principle of separation. Then, on the basis of shape of the chromatographic bed. So, if your chromatographic bed is two-dimensional, it could be either TLC or paper chromatography. If your chromatographic bed is three-dimensional, it is column chromatography. Third is on what mobile phase you are using. If you are using liquid as your mobile phase, it becomes liquid chromatography. If you are using gas as the mobile phase, it becomes gas chromatography. If you are using combination of both of them, it is supercritical fluid chromatography. Excuse me. So you can see these types, right? This is your thin layer chromatography. This is your sort of column chromatography. This is your paper, HPLC, HPLC and your GS. Okay, this is how it looks. So now, certain terms that we are going to explain. First, influent. It is the liquid that enters the column. Effluent, the liquid that leaves the column. Okay, so the solvent which you are using or adding to the column is called as an influent. The solvent which comes out of the column is called as an effluent. Okay, elution. Now let me explain. Suppose this is my chromatography column. Okay, please excuse, I'm using a mouse to draw. Now, in this chromatography column, I have a resin which has hydrogen ion. Fine. From the top, I add aqueous solution of, say, NaCl. So basically what I'm adding here is sodium ion. Fine. Now, sodium ion has a positive charge. Hydrogen ion has a positive charge. Correct? So now, the solution that I add is called as an influent. Right? What happens inside the column? Inside the column, sodium replaces hydrogen. So now, what comes out from here is hydrogen in the form of its ion. then this will be called as the effluent. Okay, so let me repeat what has happened now. I was having a column. In that column, I was having an ion exchange residue in its H plus form, right? What I did now is I passed sodium chloride solution. So sodium ions are passed. What happens in the column is sodium ions replace hydrogen. So hydrogen is sort of kicked out from the column. Sodium takes its place, right? Now what will happen? What I'm adding to the column is an influent. What comes out of the column is the effluent. Okay, अभी की स्टोरी क्या हो, कहाँ तक आए हम लोग? कॉलम के अंदर सोडियम आयंस है. Now I want to remove those sodium ions. So now I can add another solution to remove the sodium ions, which will effectively remove sodium and get in place of sodium. So that solution which we add is called as an eluent. And the process is called as elution. And what you get out from here, so suppose I add potassium chloride. Okay. So बाद में क्या होगा second step में? अभी sodium will come out. Now the sodium is called as the eluate. Elution के लिए जो हम लोग use कर रहे हैं, eluent is potassium. And the process of replacing sodium by potassium is called as elution. You can use this terminology for every type of chromatography. It is more easy to explain with the help of ion exchange. That's why I'm using ion exchange. I will repeat the entire thing again because I know this is slightly confusing. Influent, anything that flows in. So whatever you introduce in the column is called as an influent. Whatever comes out of the column is called as an effluent. Right? The solution that you use for elution to remove anything from the column is called as an eluent. What you get out of the column is called as an eluate. Eluate can also be effluent. Eluent can also be influent. You understanding what I'm trying to tell you? And the process that happens in the column is called as elution. Okay, so now let us come to paper chromatography. As I told you, it's an analytical technique. I will first explain to you what exactly I want you to know for paper chromatography. What is done? You take a Whatman filter paper. I repeat the difference. Why Whatman filter paper? Because your ordinary filter paper has irregular arrangement of fibers, which will not support the movement of solute and solvent. So that's why we use a proper Whatman filter paper. So what we do is on the Whatman filter paper, that is, a stationary support. Fine. So you take the paper. On that paper, you place your sample. And you place this in a mobile phase, which will travel up the paper. I'm going to show you a small video clip for the same, so you will understand it more better when you see the video. Now, let us take an example. Suppose I have two people. One person weighs, say, 40 kg, other person, say, weighs 80 kg. And I tell them, okay, fine, run. Say a distance of 4 kilometers. It's very logical that a person who's weighing 80 kg will move slow. And the person who weighs 40 kg will move faster. So what are we doing here? Let us come down to molecules. So if I have two molecules, one having a larger molecular molar mass and the other one having a smaller molar mass, and I subject it to paper chromatography, the one with smaller molar mass will move faster. One. So it will depend on the molar mass. Second, it will also depend on how much the solute likes the mobile phase. So if the solute likes the mobile phase, it will move faster. If it does not like the mobile phase, it will stay where it is. I don't want to go. Right? So let us come to what is there on the slide. So paper chromatography is a technique which we use for separating and qualitatively analyzing the components of mixture. You can use this to test purity and identify impurities. So what is the principle? The components of the mixture get separated between a stationary and a mobile phase. The stationary phase is a filter paper of high quality, quote unquote, it is Wattman filter paper. And mobile phase will be a solution which can travel up the stationary phase. The separation of the component depends on what? The strength with which they get adsorbed to the stationary phase and how readily they dissolve in the mobile. So due to different molecular structures, each one will have a different solubility. More soluble, it will travel. Less soluble, it will stay where it is. Now in case where we use water as a mobile phase, you consider polarity also. Okay, I won't go to the applications right now. Let us go to thin layer chromatography. So what is done? The sample solvent. You apply the sample on a solid adsorbent. Before that, how the plate is prepared, you will be shown this tomorrow. So I'm not going to talk of it right now. Simply what is done is, you take the solid adsorbent, you dissolve or you mix it in a suitable solvent, and you coat a you coat a support with the adsorbent. You activate the plates, you place the sample, and you place this in a mobile phase. As the mobile phase rises, by capillary action, the components dissolve and move up the TLC plate. The separation will occur on the basis of differences. Weakly absorbed components will separate first and strongly absorbed components will separate later on. Okay? Now, how do you do the measurement? So you can see this. I will. Okay, so observe the visual. You can see two spots. Whatever is here, this one is your sample. Okay, the one that you see in pink is your TLC plate. The one that you see in white is your sample. So let us see what is happening again. Ready, steady, and go. Sorry, I went the wrong way. Which one is going faster? Yellow. So it means your yellow spot or your yellow component likes the mobile phase more than the blue component. Okay. So blue is more polar. So it attaches to the stationary phase very strongly. And because it is attaching to the stationary phase very strongly, it moves very slowly. Whereas तुम्हारा जो yellow component है, it is less polar. So it is attaching weakly. And because it is attaching weakly, it moves very fast. Let us repeat this again. Can you see this? Yellow goes fast, blue goes slow. The reason is blue is stronger adsorbed and separates very slowly, whereas yellow is less polar, absorbs weakly and goes very fast. Okay. What we do here, we calculate the RF value for the component. What is RF value? Simple. Now you can see here, this is the original plate, this is the developed plate. क्या difference है? पूछे. Original plate है, you can see the spot here, this is my sample. I'm dipping that plate in a solvent. My solvent carries the sample and separates it into two components. Now, if my components are colorless, then what I do, most of the cases, I keep the plate in a chamber of iodine. So color develops on the plate and I'm getting two spots. What does this precisely mean? That मैंने जो sample रखा था, that sample has got two components, 1 and 2. Okay, component 1 is more attached to stationary phase, whereas component 2 has got a greater affinity to the mobile phase. Okay, now you can see this distance. This is the distance traveled by the solvent. ये मेरा baseline है, मैंने इसके ऊपर mark डाला है या sample डाला है, and this is the point where till where I'm allowing the solvent to move. So this distance is the distance traveled by the solvent prime. Then this is the distance traveled by spot 1 and this is the distance traveled by spot 2. Let me check again. I will repeat the entire stuff again. This is my first plate. Right? This is the developed plate. Developed plate means you carry out the chromatography. You develop color by using a suitable reagent. अगर तुमको suitable reagent कौन सा है मालूम नहीं, either use UV light or you can use an iodine chamber. Right? You first calculate or you first measure how much distance the solvent has traveled. Then you measure how much distance your first spot has traveled. And then how much distance your second spot has traveled. So you calculate distance traveled by the spot upon distance traveled by the solvent. So for sample 1, it will be 22 by 65. And for sample 2, it will be 50 upon 60. You call this ratio as the retention factor or RF value. Now finally, we come to uses of chromatography. So it is used to examine a mixture, its components, and how these components are related. Then to identify components of a mixture, to purify and isolate a sample, to determine the amount of the mixture or the components present in the mixture. Now these are some real life applications. In pharmaceuticals, when you are carrying out maybe a reaction for a drug or drug modification, and you want to find out. Now, let me give you an example. Suppose I have, say, some of you might know this, some of you might not know this. I have, say, a nitrobenzene substance, right? And I'm converting it to metadinitrobenzene. Right? Now just visualize. I will not draw the structure. Just visualize nitrobenzene is what? Benzene ring to which one nitro group is attached. And I'm converting this to metadinitrobenzene. So what I'm doing is nitration. It's a nitration reaction requires a high temperature. So what you do, you take nitrobenzene in a suitable solvent. You add nitrating mixture to that and you do vigorous heating of both. Okay, now the reaction requires 1.5 hours of heating. अभी 45 minutes के बाद मुझे लगता है मेरा reaction complete हुआ कि नहीं या मेरा reaction हो रहा है कि नहीं. So what will I do? I will take, a TLC plate. Excuse for the lines that I'm drawing. This is my baseline. Here I will place nitrobenzene and here I will place the reaction mixture. So this is the raw material and this is the sample. Okay, pure nitrobenzene, and I will place my reaction mixture and I will carry out the chromatography. This is the spot for nitrobenzene. Okay, if a reaction mixture gives me only this spot, मतलब मेरा reaction हुआ ही नहीं है, nitrobenzene वैसा का वैसा. If I get two spots, one for metadienitrobenzene, one for nitrobenzene, then my reaction mixture or my reaction has happened and I'm getting my product. So this is to, understand the course of a reaction. In hospitals, in forensic labs, we use chromatography for detection of drug abuse. Why does it become important? If a person is into drug abuse, if you want to find out whether he has taken any particular type of drug or whether he's under the influence of a particular type of drug, his blood sample, maybe urine sample, sometimes is subjected to chromatography. From chromatography, you can find out which drug, which different types of drugs, everything you can find. Then law enforcement, you use to compare a sample found at a crime scene to samples from suspects. Environmental, you use it to determine the pollutants in water supply. And manufacturing unit to purify a chemical or to check whether the product is being formed or not. Okay, now I want to show you a small video clip. Just 1 second. I just want you to see this video clip. This will help you to understand what concept I have talked about. Just give me a second. I'm trying to bring in the clip. Just one moment. I'm going to show you two video clips. Now, I just want you to see this animation. It gives you a very good idea of what chromatography actually does. I'm putting myself on mute because if I'm on mute, then the sound does not lag. one more small video I would like you all to see.
Grambling happens very quickly and confidently. So
Here one quick biochemistry basics here. Let's talk about paper chromatography. Paper chromatography is a common technique widely used for separation of terpenes, amino acids, DNA bases, etc. In paper chromatography, paper acts as a solid separating material. The water molecules present in the course of the paper acts as a stationary phase, while a mixture of different solvents such as ethanol, ether, etc. can be used as a mobile phase. The sample is applied on paper using a capillary.
So what you can see here, the sample is spotted on the paper. You allow the mobile phase to move. As the mobile phase moves, it breaks your sample into 4 different components, right? So you can see the solvent reservoir is here, and your sample is, or your solvent is moving up. This is another kind of paper chromatography called as descending mode, where your solvent reservoir is at the top and the solvent descends on the support. The third one is radial mode, when the paper wick is attached, you dip the wick in solvent chamber and your spot moves radially as the solvent moves in all directions. Okay, this is radial mode. Then you have 2D paper chromatography, wherein, see what is done, this is very interesting. The movement of your solvent is in this direction. So your spot gets separated into different components. You can see there are 4 different components. Then you shift the paper so that now the solvent front moves perpendicular to the initial solvent. मतलब initial तुम्हारा solvent front ऐसे move हो रहा था, now the solvent front moves in this direction. This is called as 2D chromatography. Hello, hello.
Yes, ma'am, you're audible. I am so sorry. We are having a technical glitch from the resource person side. Ma'am, you are audible to us. Ma'am, can you please unmute yourself and speak?
I have mute myself. Am I audible?
Yes, ma'am, you are audible.
Okay, okay,
Yes.
fine. So now, let us. Everyone has got the material that we have told you to get ready for the session. Siddharth, can we, activate chat boxes activated for people? So I want
Yes, ma'am. Chat
you
box is
to
open for
tell me
me.
how. Yeah. Okay, okay. Now, each one of you, I want you to take a plate in which you will be. I'll switch on my video. Just give me a second. Mayuresh,
Yes, ma'am.
till the time I get things here, it's just on the other table. I will just carry it to my table. You just give them instructions about today's feedback forms and all.
Yes,
Okay. Maybe
so guys, please do the activity as was given in your first document, primary document, which was supplied to you. You will need a chalk, a plate, and some ink for the current activity. Please get your material at your places so that you can commence with the activity at your spot. It is as per your wish. You can open your video for the activity. The resource person as well as some of the volunteers will also keep their videos open so that you can trace them and check and learn from them how they are doing the activity and get a more hands-on experience for the same. The feedback link and some other documentation and notices will be given to you post the hands-on activity session that will be have till now. Stay tuned. Thank you so much.
thank you, Mayuresh. I hope I want you all to do this. Can you see this? I have taken a glass. You can take a steel plate. In this, I'm going to put a drop of ink. I just want each one of you to understand what is stationary and mobile phase and how capillary action happens. What I have done is I have prepared a solution of ink. Okay. Now, I want each one of you to do this. You can see the ink rising up in the chalk. You can see this. It rises up very slowly. I have used common fountain pen ink. You can use whatever ink, water soluble ink that is available with you. Each one of you can do this. I want you to keep this in the ink solution for at least 3 to 4 minutes. I would want people to switch on their videos so that we can see what is going on. Mayuresh, we can do that.
They can switch on their videos, ma'am.
Yeah, please switch on your video so we can see what is being done. You can see here.
Please observe your screen for voluntary video.
Yes, everyone, we would be. Yes, that's too good. Participants, please switch on your video so we'll be able to see what you're doing. Now, I'll tell you what you will observe. You will see the ink rising up along the chalk. The mechanism by which it rises up is capillary action. Now, this was the most primitive type of a chromatography column used by scientists when things like silica gel and activated silica were not available. They had done it with calcium carbonate. If you want to see this, you can pin Nandini's video. You can see steady movement of the ink along the chalk column. If you are using an ordinary fountain pen ink, you will see two colored bands. One is violet in color, the other is sky blue in color. So the ink that we use for fountain pen, of course, today's generation we hardly use fountain pen, but the fountain pen ink, which is a water soluble substance, has got two colored components in it. One is the violet color and the other one is the sky blue color. Okay, if you want, I can show this to you. Yes, you can see this. There are two different colors separated. There is a violet one, there is a sky blue one. Now, if I want to make this quantitative, what I can do is I can cut those parts, extract the color pigments from there. Right? You can see this. I'll use a pen to show you. This portion is the violet ink or the violet dye. And this is, sky blue dye. Right? If I want to further go ahead with this, I can take this portion of chalk, remove the dye from there by some suitable extraction method and try and identify the dye. Okay, now let me give you an extension of this. The same thing I can use for food colors. Now let me explain this. Most of you eat Chinese food. Right? I'm speaking the wrong thing in front of a crowd, but let me explain it this way. Many of you must have eaten pav bhaji outside, right? Okay. अभी जो पाव भाजी तुम्हारे घर में बनती है और जो तुम बाहर शॉप में खाते हो, next time you eat it outside, you see the difference. The one which you eat outside, after eating, your hands stain red. घर में तुम कुछ भी करो, your pav bhaji will never have that red color which stains. Why? Because in restaurants and hotels, they do add food colors. Now, of course, food colors, again, there are qualities. You have a food color which we can use safely without any side effect. There are certain food colors which are harmful. So, जो unbranded food colors रहेंगे, you obtain it as a byproduct from coal tar. These are called as coal tar dyes. This is a very easy technique. Like, I have shown you something at home. You can do this at home. You can take a food sample, extract it, put the extract in water, and you can find out how many types of food colors are present. It could be a ketchup, it could be anything. You can find out how many different components are present. Suppose it's a water insoluble food color, then you can extract the food sample with acetone or alcohol and you can use it for chromatography. Fine? Right. Now, with this, I think I have come to the end of my session. Yes. Of course, I have come to the end of my session. I have tried my level best to explain what is chromatography. We are going to build on this further tomorrow. You will be talking about a special chromatography technique, that is HPLC, which is most advanced technique in chromatography. So now can we go ahead with the question and answer sessions? If anyone has any questions, you have been instructed to put it in the chat box.
Thank you so much, ma'am, for such an informative session. Proceeding ahead, I request Ms. Urvi Achutan and Mr. Shivam Sharma from Department of Chemistry to begin with the question and answer session. Participants are requested to please post in their questions in the chat box. The chat box is now available for your questions. Thank you.
So thank you, Siddharth. So as we know, the science is all about asking questions. So we have some question in the chat box for ma'am. So our first question is from Mihir Umrigar from KC College.
I'm sorry.
Yes, ma'am.
I'm sorry, I'm not able to hear you, dear.
Hello, am I audible now? Hello.
Yeah.
Hello, ma'am.
Yeah. Now you're audible. Fine.
Okay. So our first question is by Mihir Umrigar, KC College. He's asking, while using iodine chambers for a colorless medium, does the entire setup also get stained or selective?
Yeah, when you're using iodine chamber, your entire slide will show some tinge of iodine, but your spot stands out. So it is just to locate the spot. Okay, so you can use iodine chamber. Your entire slide will show slight, shade of iodine, slight deposition, but wherever your spot is, you will get a stronger colored spot. So you can easily identify. Next question, please.
The next question comes from Archana Soni from KC College. So apparently the ink she used was not water soluble, so she wants to know what else she can use instead of water as a solvent.
If your ink is not water soluble, ideally you can use alcohol, but alcohol is not so freely available. So you can try, take that ink in acetone water mixture. Less amount of acetone is your nail polish remover. Take a acetone water mixture, less amount of acetone, more amount of water, put that ink in the mixture, and then you can do the same stuff. Archana, in fact, I want you to send me a photograph of what you do. You have my number. You can send me a photograph of whatever you have done so that we can include it in our report when we write on this. Yes, next question, please.
Thank you, ma'am. So next question is by Suchismita Goshal from KC College. That can we separate any mixture or are there any limitation in this method?
No, you can separate the mixtures provided you select your solvent properly, or you can, separate the mixtures provided you use a combination of solvent as mobile phase. So it all depends on what you're dissolving your sample and what combination of solvents you're using as your mobile. Next, please.
Thank you, ma'am. The next question is from Kumkum from KC College, who asks, can't we use another elemental chamber instead of iodine chamber?
Instead of iodine chamber, you can use a UV chamber which will directly make your spots visual. But iodine is the most common because it is very easy to procure in a lab and very handy and very safe. In fact, at PG level, some of your participants are from postgraduate chemistry. At PG level, we commonly make iodine chambers and keep it ready so that we can, do it rapidly and check it out rapidly. So, as far as a lab is concerned, a college laboratory is concerned, iodine chamber is the best option. Anything else?
We are still waiting for the questions, ma'am.
I would like to intervene here. I would request the participants to please keep an eye on the chat box. We'll be posting the feedback link for the session, for the day one session. So please have an eye on the chat box. Thank you. And the chat box is open for questions. We can, I think we have one more question.
Yeah.
Yes, ma'am. So the question is by Shubham Jadhav from RJ College. How the UV light makes visible the compound on TLC plate.
Okay. UV light basically brings about transitions. So when transitions happen, when electrons shift, your compound, sort of shows a different color, which you can easily visualize on a plate. I suppose you must have heard of electronic transitions that happen. So that's what is happening when you are exposing your compound to UV light. Any more questions? You can mail your questions to us. Yes, one more question, last one now.
This question is from Santosh Kamble from BNN College, and he asked if chromatography is used for separation of petrochemicals also.
No, you cannot use chromatography as such. If it is identification, yes. But separation of petrochemicals, if you know distillation, destructive distillation are far more better techniques than using chromatography.
So we have one more question here.
Yeah.
Sorry, Mariam. So what made scientists switch over the calcium carbonate to different materials for separation?
I will not say switch over for separation. Calcium carbonate had its own, problems. Sort of its particle size. The particles are not very fine. You cannot go beyond a particular size of the particles. So if your medium, your stationary phase has got a larger particle size, the stationary phase will be more coarse. And for chromatography to happen, you need a fine stationary phase. So that's the reason people were looking out for things which are more fine than calcium carbonate. So then came in silica, alumina. All these things were finer. The particle size was more even and fine. And that's the reason shifting from calcium carbonate happened. Means till the time nothing was available, they were using calcium carbonate. But as it shifted on, you get better materials available. Just say, for example, हम लोग, color TV था पहले. Then came your LCD LED. So because we didn't have anything, we were using a color TV with a color, your cathode ray oscilloscope. That is your CRO. Now we have better options, so we will never go back to that. You get more picture clarity, something of that sort. So maybe after another few more years, we may come across something more better than even alumina and silica. So that's the reason calcium carbonate is shipped to. No, calcium carbonate, I read the question myself, don't worry. Calcium carbonate cannot be used for all. अभी हम लोग घर में काम कर रहे हैं, household level fine. I tell you to use chalk. Now, if the same thing you do with a TLC plate, you will get a better separation. The bands will be more clear. With chalk, it's very clear the particles are not even and fine. So your separation will happen, but will not be very defined. As you can see now, you may have kept your chalk in ink for some time. You see the bands that you get. You get two colored bands on your chalk. One is violet, one is blue. If this was the same thing was done using a TLC plate, the separation would be more proper.
I think any more questions can be mailed. Yes, ma'am. Any more questions can be mailed to our official email ID, which will be sent to ma'am, and the answers will be delivered to the respective participant. Thank you, ma'am, for patiently answering the questions from our participants. And thank you, Urvi and Shivam, for taking up the questions. The feedback link is posted in our chat box. I request the participants to please fill in the same by 9 p.m. today. Now, I would like to call Ms. Sonia Joshi to propose the vote of thanks for day one Bandit Up event.
Thank you, Siddharth. Good evening, everyone. I'm Sonia Joshi from third year Life Sciences. As we conclude the day one of our insightful workshop, on behalf of Department of Life Sciences and Chemistry, I would like to extend a hearty gratitude to our principal, Dr. Hemlata Bagla, for being a constant pillar of support and for guiding and motivating all faculties to take up many more such interdisciplinary activities. I would also like to thank our Vice Principal, Faculty of Sciences, Dr. Tejasri Shanbag, for delivering the welcome address and also guiding us towards greatness. A special thanks to Mr. Justin Maria, Vice Principal and Coordinator of Examinations, for gracing the webinar with his presence and delivering words of wisdom and motivation. A hearty thanks to Dr. Sheila Balecha, Associate Professor from Department of Chemistry, for providing guidance and support at every step of the workshop. A big thank you to Dr. Sagarika Damle, HOD, Department of Life Sciences, and convener for DBT Star Status, under whose mentorship and constant motivation the whole workshop had been set up and put into action smoothly. I would like to extend tremendous gratitude to our resource person for day one, Dr. Yogita Shinde, who has provided extremely interesting and educational insights regarding the basics of chromatography and intrigued everyone with the very simple yet effective activity to understand the same. Lastly, a big thank you to our participants without whom this workshop wouldn't have been plausible. Thank you to each and every faculty member, postgraduate student, and undergraduate student who have been an audience to the first day of our workshop. A special thanks to all our volunteers who made the workshop technically and functionally sound. Hope you all had a wonderful session on day one and hoping to see you all for the next 2 consecutive days because I'm sure each day will be more insightful than the previous one. Thank you.
Thank you, Sonia, for the vote of thanks. All participants, please note that the participation in all the activities is compulsory in order to get a certificate at the end. Please make sure that you attempt all the forms and the links shared with you in the feedback in our chat box. Thank you so much for joining with us today. Stay tuned with day two Banded Up. Thank you so much for everyone for joining.
Please note, the requirements for tomorrow are open. You all please note them down so that all of the things are there with you when we start tomorrow's session. Thank you so much. Ma'am, can we conclude the session?
Yes, I think we can conclude the session for the day. Sagarika ma'am? All organizing team, please stay back. Let the other participants leave.
Yes. Participants, you are free to leave the session. Thank you so much.
So shall I